Starting recording, and let's begin with it. All right, so good morning, everyone, and thank you so much for joining this session this morning. I am Vidyavrata Agarwal. The session is going to be about microservices architecture. It's a very broad topic. Here I will try to touch base a very bare fundamentals of microservices. Many people do not understand what microservices architecture is, how to compare it with the previous architectures we had in place, or many organizations are still following along, what it takes to begin with microservices, how to spin teams which work on microservices, how to find even if my organization or my project is a good candidate for microservices architecture or not. And then I will give you some real world scenarios, how industry organizations are solving it. And then I will also talk about some patterns. There are tons of patterns in industry, like architecture patterns, but for microservices, there are few which are very must to have. If you are working on microservices, always keep those patterns in mind, and I will talk about those. And as I said earlier, if you have any questions, do not hesitate to reach out to me, drop me an email or LinkedIn or blog post, whatever, and I will see how I can cover it for you. So let's begin with it. Before we do it, let me give you a little bit background about myself. So I have 18 plus years of experience. I have more, but I like to call it 18 plus because first few years were just sort of a struggle, surviving myself, doing odd jobs in software industry, which however turned out to be a cornerstone to help me establish myself. But when I talk about like software thing, I like to call it 18 plus years. At present, I'm working with as a principal architect with T-Mobile. It's a telecom company. We are the third largest in United States of America, and we are a software company who are in telecom domain. It's a pretty broad domain, I would say, in comparison to other domains, even e-com and all, because we do have e-commerce flavor. We do have a care, our data centers. We do have care, call centers. We have our retail stores. So we are sort of mix of everybody. And I'm also a Microsoft MVP, which is the most valuable professional for 6 times. I'm a C# Corner MVP, I think, for 7 years by now. I am Target Certified Architect. I am also a Certified Scrum Master. I have almost a dozen Microsoft certifications. Many of those are expired now. Microsoft has a habit of keep changing, but that's okay. I'm a published author for 5 books, which you are seeing right now here. The extreme left, in the red one, C# 2005 databases. Sorry, C# 5.0 databases was my latest. After that, I did not write anything. But these are my books, over a dozen almost. I'm still reviewing a book on Azure. So I like to do review. I'm a technical reviewer of already almost over a dozen books, and I keep doing it whenever I get time and approached by some publishers. So I have done review for O'Reilly, PacketPub, and Apress. One thing, whoever has joined, you can even pass it around. When I do this PacketPub thing, I get some tokens from them. If any one of you need a book, not a hard copy, a PDF or a Mobi, if you have Kindle device, send me an email. The website is PACKT, as you can see here in the bottom right orange thing with a white color text. PACKT, packet pub, PUB means publication.com. Go there, find a book you want, and send me the link. Send me from your email or text me, whatever. When I say text me, you might not have my phone number, but sometimes LinkedIn shows my phone number if you are in US or somewhere. But email is better, or send me a message on LinkedIn, and I will download that book and give it to you free of cost. Okay. Again, the website is packetpub.com, PACKTPUB.com. All right, so moving on. So before we really get into a microservices architecture, my style of learning has always been not jumping into the greatest and latest. I want to understand what was the predecessor, what was happening before it. However, I know because I evolved in this industry, but there are many people who are joining industry new, changing jobs, Even what about those who are getting their feet first time into the software industry, right? They might not know what monolith or what service-oriented architecture is. So service-oriented architecture is a little bit different than monolith because many organizations and uh, documentation on architecture says that service-oriented architecture has to have a service bus. Uh, Call it ESB, call it whatever you want to call. There is a service bus or enterprise service bus which will take care of communication between the services. However, I have worked on both, and in my view, both are almost same because none of them are actually microservices. So let's jump into understanding what is the landscape which was before microservice, and many organizations still exist in that world. So think about any MVC based application. I'm talking primarily for API side. There are other patterns as well than MVC, but those are primarily for front end. If you talk about server side architecture, which is microservices and all, then you need to rely heavily upon MVC, regardless of you use C#.NET, you use Java Spring Boot, or Golang, or whatever you use, right? So think of an MVC pattern-based application where what you have is in your code, you have your controllers, and then you have your POCOs or POJOs. POCO and POJO, they both are industry terminology. Both are, as you can see, the difference is only C# and Java. J stands for Java and C stands for C#. So if you happen to be in Java world, you will have POJO classes, and if you are in C#.NET world, you will have POCO classes. Now, all those controllers, your models, your views for the front end, of course, but if you're on server side, your controller, your model, you and your the common code you have, like cross-cutting concerns, logging, security, data access layer, repositories, and all. What you do, everything you do in one project. You open it in Visual Studio or IntelliJ or WebStorm, whatever you are using as an IDE, integrated development environment, and then you just start working on it, building on it, and at the end you produce one artifact. So if you see here, this is the whole thing. This is how your project will look like today. There might be few further layers, but those layers would be DAL, data access layer, a business logic layer, things like that. But all your controllers would primarily be in one single place. And when you will build that project, all of those will be built once as one single artifact. Call it DLL, call it EXE, call it jar if you are in Java, um, and things like that, right? So what happened in this case is that their database is also one. You have only one database, one big monolithic database. Uh, Call it SQL Server, MySQL Server, it doesn't matter. A database is a database. You have SQL, uh, structured query language. You have joins, relational tables, primary key, foreign key, all that good stuff, and all that in one. If any one of you is able to relate to it, because I have done it even until a few years ago, I was working for a client in California. We did the almost same architecture for them because I will explain why, because microservice is not a fit for everyone, right? And code is a code. It's very easy for me to dissect any project into microservices, and I will talk a little bit about it as well. So this is what monolith is. Think about one big chunky code, one project, and one big large monolithic database. That's what monolith is. And that's why I will keep showing these images. So it will live in your memory forever. So I will keep showing these images time to time because you will have a visual clue of it in this. Now, before we go any further and really jump into microservices, it is also important for all of us to understand why monolith, what advantages or benefits monolith has. Because believe it or not, I am a big supporter that there is no good or bad architecture. Always remember that. You are always picking your trade-offs. You are making a decision based upon a trade-off. Many times people are biased, which is sort of wrong at times, but you have to see why I am picking monolith architecture or service-oriented architecture or microservices architecture. Someone do not have to be a resume driven. Do you know that there is an anti-pattern in architecture as well? We call it resume driven development. Resume-driven development is that when somebody wants to enforce a technology into a project because you want to learn that, that is not a good idea to go that way. You should always put your organization and the project and team's benefit first. However, many times you may have to push towards a new technology, regardless of you have worked on it or not, but not because you want to get your hands dirty on it. If you want to do it, there are tons of ways to do it. A lot of free stuff roaming around, free code, blogs, websites teaching stuff. Do it on your own, but don't do it in a project. So let's learn about Monolith first. So I will be a little bit short on these things. This text is here. This presentation will be shared with you. You can find it on my GitHub. I will send, when I will publish this on my LinkedIn, I will share all those links. And even if you will search my details, you will find my GitHub and you can find it later, not at this moment, but after I'm done, I will upload it there and you can find it. And I will share the link. So fewer cross-cutting concerns. First of all, you can read all that stuff here. I will not read it for you, but while I'm talking, you can stare at it. You can get some keywords and sentences out of it and start making sense. Now, before I get into it, I really want to explain you that why it is called cross-cutting. Many people do not really understand why it is called cross-cutting. So think about layers. Everything is horizontal. Okay. At this moment, I'm moving my hand from right to left, one layer. Then again, I'm moving my hand 1 inch down, right to left, another layer, third layer, fourth layer. What these layers are? These layers are your presentation layer, application layer, data access layer, business logic layer, right? Think in that way. Now, when all these layers are laid out in your architecture diagram, what does cross-cutting mean? Now think about on one of the corner, whether it is right or left, you are drawing a line top to bottom. Means you are cutting all these layers top to bottom. How you cut cake. Think it that way, that you are cutting cake. So all the layers of the cake are being cut by that knife which you ran through. Why do we call it cross-cutting? Means security. It's a cross-cutting concern because it cuts through all the layers, means it is applicable to all the layers. That's why we call it cross-cutting concerns. What does concern mean? Concern, why do we don't call it requirement? A concern is not a requirement. Always remember that. Concern can be defined into a requirement, but many times that's why many organizations, many projects do not have security features to that level what they're supposed to have. They do not have performance to the level which they're supposed to have. They don't have logging. There is no logging happening anywhere at a centralized location, right? There is no audit trail. There are no monitoring. So why not? Because they never thought about it. Many times we call these cross-cutting concerns as a non-functional requirements as well. As architects like to call it NFRs. NFR, three-letter word, NFR, non-functional requirement. The problem we have today is that many times we only focus on functional requirement. Tell me how my website will look like. Tell me where would I click. That's all good, but there is other magic happening around and underneath which make this presentation layer work. If you do not like a website, what do? You quit. So that's why you need to pay attention there. But once user is engaged with your website, what happens behind the scene is happening from a lot of things, moving parts around it. So one word here which I want to explain you is DOS. DOS stands for denial of service attack. If you are on a distributed environment like microservices, it's DDoS, distributed denial of service. But in Monolith, it's not distributed. Hence, the word is DOS, denial of service attack. Less operational overhead because it's just one single large application. You can choose Azure's app service or web app to deploy it into regions. Each region has multiple availability zones and you are done. That's it. You deploy one big chunky block. There is one endpoint. You hit that endpoint, everything is /customer /something /orders /something /payments /something. Everything is at one place, right? So less operational overhead on the team because you are not watching multiple things. The next one is performance. Performance is always better in Monolith because everything is sharing the same memory. It's all in the same application domain, if I want to use a .NET terminology, or in the same memory area. So you are not making network calls to go from one service to other service. However, those calls are exposed via HTTP or REST to your client applications. Let's say you have a mobile phone, a tablet. You are making a multi-device application, which can run on different devices. You are using Angular and all that responsive web application and whatnot. Then they need to access that by HTTP, but within the services. It's not IPC or RPC. You know, it's just within the same memory. You just make a call like you are calling a function in an object-oriented program. So those are the benefits you get. And then let's talk about some disadvantages. Disadvantages are deploy all or none. And whatever are here, pros, benefits, they will become the cons in microservices, and whatever are the cons, they will sort of become benefits in microservices. So the coin will flip when we go to microservices land. So cons are deploy all or none. Now I have done it multiple times when I was working on a monolith or service-oriented architecture-based project. Even if you make one line change, you have to redeploy entire stack. When I say entire stack, does not mean I have to redeploy my UI also. If I'm doing only server-side coding, which I was writing the REST APIs, then I have to redeploy entire REST API through the CI/CD pipeline, which we did in those days. It was called VSTS on Azure, Visual Studio Team Services. Before that, it was called VSO, Visual Studio Online. That's what Microsoft started with. Then they call it VSTS, Visual Studio Team Services. And now, very recently, they changed it again, and they call it Azure Devops. So all three are same. So we used Azure pipeline at that time. So I have to rerun it and deploy it to Azure for the production and lower environments like Dev, QA, and whatnot, right? So it's deploy all or none. I think this sentence, deploy all or none, is self-explanatory, but you can keep reading the text. Everything is in front of you. Scale all or none. When you are writing something for a larger organizations, scalability is a big concern. And there are only two ways you can scale. There are only two directions. You can either scale up or down, which is also known as scale up is vertical scaling. Many times we call it down is lowering it down, means bringing it down, lowering the performances and the things you have. The other one is scale out. Scale out is you are going horizontal. Think about it this way. Let's say I have a database instance, and rather than me having multiple instances of the same database, I chose to have the same database growing bigger in size. Bigger in size, of course, in terms of number of records, but in terms of how much memory that box will have, how much RAM it will have, how much hard disk, what type of hard disk, what type of microprocessor, what type of server. If you are doing a VM machine, you can pick a Godzilla machine to run your database on it, and it can handle all the load of entire world. But the problem with that is when you do scale up, which is called vertical scaling, because you are going up, you are increasing the memory, RAM, hard disk. There is a limit. You cannot go beyond that. Think about a scale. You want to serve entire world like Amazon, Netflix, Facebook, right? You cannot keep going up. So what you do, you scale out, means horizontal scaling. Instead of that, you start having multiple copies of the same thing. Think about WhatsApp and all. How do they do it? If you look at their design, system design is a different topic altogether to talk about. I don't want to spend time on it, but it's a different thing. So in system designing, what happens is you think, okay, I need to shard my database. So if I'm building a website which is serving America and Indian customers, if I want, I can design my database in a way that American customers will be in one database, Indian customers will be in Indian database. And in there also, I can break it apart by zip code basis, right? I can make so performant that in Washington, there is approx 719 zip codes in Washington of America. There are two Washington, by the way, Washington, DC and Washington. Washington, DC is near New York. I am in Washington of Northwest, near Canada, where Microsoft is. Redmond. I live in Redmond. So, and Seattle. Seattle is the main airport city. So what happens is there are approx 719 zip codes in Washington. If I want, I can shard my database to make it performant, NoSQL and whatever, that each person who is coming from a zip code will be stored in that table only. Now, what I'm doing, I'm not doing a scale up, I'm doing a scale out. So see how I've broken it apart into smaller pieces. These all are more like architecture discussions, but I'm trying to go a little bit in detail, and hence I may be a little over than the time since we started late, and it may go a little over. If any one of you have to drop, feel free. Um, the last one is single point of failure. Many times it is also used as a short form SPOF, which means single point of failure means if since you just keep growing one server in memory, making it bigger with resources and infrastructure it has, then you are buying into a single point of failure. If that server is down, then your entire functionality is broken. Whereas the other approach, when you're scaling out, you have multiple copies of same thing, or you are sharding and distributing data across small databases, then maybe database for one zip code might be down, not for the entire zip codes, right? And then when you do it and you are on cloud, any cloud, AWS or Azure, Oracle, IBM, whatever you use, they all are following and catching up with each other. You will choose reasons and availability zones and whatnot, right? So their chances are you will not have a single point of failure. Our next one is about what is microservices in a plain simple terminology, and it has all the good keywords here as well. A microservice is a tightly scoped, loosely coupled, strongly encapsulated, independently deployable, and independently scalable application component. That's what a microservice is. Global microservices market is supposed to be, going up to $33 billion by 2023. Microservices are picking a lot. Every organization is investing into it. Think of any small autonomous service which works together towards a business domain is considered a microservice. So think of your monolith architecture earlier. You had all these things together. Here you are breaking apart everything, and then they all will talk to each other. So number of hits increase, number of connections increase, but there are pros and cons, of course. So before anybody wants to start about microservices, you have to understand how to begin with microservices. So the keyword to begin with microservice is called a bounded context. Think of bounded context as a domain model. So domain model is, this is very heavily inspired from domain-driven design, which is almost 17 years old. Eric Evans started talking about domain-driven design back in 2003. And his concepts of that time are being utilized by microservices today. However, microservices is not new. It has been around for 5-6 years when people really started adopting it. I have been using it for past 4-5 years myself. But think about it, how much gap we have between 2003 to at least 2012-13, right? So this was our monolith where everything was one, everything is deployed once, one big database. Here, what we did, we are breaking apart everything into small services. And how you do it is you have to find the domain within your project. So you find that, okay, what is the customer domain? What is payment? What is order, shipping, billing? The problem we have in today's monolith on the left side, black and white diagram is, ask yourself, let's say tomorrow in your project, you have a requirement to send an email, right? You need to send email to somebody, to your customers, or text notifications or whatever, right? Now, who are you sending it to? The answer is, I'm sending it to customer. Many architects, even devs, what the habit they have is they will start coding that thing in customer controller because you are sending it to a customer. And to a certain extent, that makes sense because it is for customer, of course. Everything is for customer at the end, believe it or not. So what you do, if you are working on cloud or something, you will just, FYI, there is a SendGrid. It's a free subscription. You can send few thousand emails, I think daily or monthly. Azure SendGrid, I have used that. It's a service from the Azure Marketplace. Very reliable. You don't have to look out for emails. It automatically retries, send you the failure reports and all that stuff to send emails, right? So if you have to send email, what will you do? You will go and open the customer controller, create another function in it, and then start typing your controller method in that to send email, right? And there you will have to, from, subject, body, and things like that. In microservices architecture, even in Monolith, I would say this is not right approach. You should create a separate controller for email and notifications. So here, if it is microservice architecture, you will spin a brand new project, call it notifications, because it's a new domain altogether. It's a notifications domain or communications domain. What if tomorrow you want to send text messages? What if after that you want to send mails by postal mail? And you continue to evolve, right? So that's how microservices thinking are. We never put anything into anything because it can be slided into that. So that's how microservice architecture look like. You can see the complexity in comparison from left to right. What we did, we broke so many things apart. So let's keep moving on with this. You will get more clarity. So this is the same view of the previous thing. Now, what happens earlier is that if you have a single application, what you do that all your feature A, B, C, think of domains like your order, payment, customer, all these things are in one, but you have multiple copies of it. See that? A, B, C everywhere. You have multiple copies of the same thing. That is what Monolith is styling. That I keep deploying multiple servers, but every server has everything. Whereas in microservice, what happens is that you are breaking everything apart. So you have multiple A's. You see, A, A, A. These all are segregated. They all are distributed across, but at some point of time, you may not have multiple copies, like 3 copies of each. Maybe that's not that important service. What if you have something which is doing background work, like 2 a.m. Pacific time, it does something, right? Even if that service is down for a few hours, nothing is going to hurt because whenever it will come back, it will self-execute. So you do not have to have 4 or 5 copies of it because it's not business critical. Business critical means it's not critical to your business or to provide you the business continuity, right? Think about if T-Mobile website goes down for a few hours, how many $1 million we will lose? Or if Amazon goes down, right? So all those things are required to have your business have the rhythm. We call it business continuity. Now, this is a real world example. It's an old website of Amazon. Amazon website does not look like this today. Sort of look like that only, but not exactly the same if you want to compare. So what happens here is, in this case, that look at the left side. There are 7 pieces, 7 red blocks I did. I intentionally covered it by the red lines here. So 7 things. What happens on the right side is there are backend services, right? Now, this backend services, there are total of 14 microservices. If you will count all of these are 14 on the backend. Now, what happens is that you have so many backend services. Let's say you are talking to, you have a payment microservice, which shows you the payment information when you submit an order. But that payment microservice actually is talking to a payment domain within Amazon, and then Amazon's payment domain either fulfill it by themselves or they go outside for a payment acquirer, like a WordPay, for example, Visa, MasterCard, PayPal. All these companies now, I think many other companies are evolving. So different vendors, different companies choose different. So they will go out and submit that information to that organization to process the payment, right? So what happened in this case is that you are talking to some external services, some internal services, and you have some internal microservices. Now, the 2 things I want to explain you is it says other internal microservices means these are your domain teams. So if this is a page, this is a browse page, okay? So this is the page where you browse. Now this page, if it is owned by one team, this team does not own all the data for whatever is shown here. This team does not own cart. Cart is owned by some separate team, right? Let's say order team. Order domain owns cart. Now what happens is there is a team which is building order microservices, giving the capability, whatever order provides, to place the order, cancel the order, track the order, and things like that, right? But when you are loading your page or the customer page to see the order details, there is not only one microservice customer is calling. When I say customer is calling means when you load the page, UI calls that on behalf of customer. There are multiple microservices are being called because on your orders page, it also shows what payment method did you use. It will show you some XXX and then your last four of your credit card and tell you if it is Visa or not, how much money did you pay. That is payment domain information. So to give you the order details page, it is calling actually order service and the payment service. Now, when it calls those two services, now think of this UI composition microservice one. Now, what this service does, when you click on order details, it calls your UI composition microservice, and that microservice calls multiple microservices to the domain, bring that data back. It has a view model. It will map the JSON response from those two microservices into its own JSON and give it back to the order details page where you will map all those fields to the UI. Now, this thing is called, the UI composition microservice is called experience microservice. Okay. So experience microservice means where is experience? Experience is what you see. User experience on the left side here. This is my user experience. To draw the user experience, anything, think about it. These 7 sections are dependent on 14 microservices. And this is a hypothetical, by the way. It's not real. But this is how even at T-Mobile we do things. I have designed for T-Mobile the architecture for order domain and payments. I was the architect for that for almost over 2 years. So I do know how it works in real, and this is the exact same thing, even the pattern which we followed. Amazon does it, everybody does the same. And there are benefits to it, which I will talk about it later. What are the benefits and all. I hope you guys are getting the idea. Here and there, I might have to pick up some speed, so please bear with me. As I promised, I will answer your questions offline if needed. So moving on, let's quickly talk about some advantages of microservices. What are the advantages we have? So the first one is scalability. Because everything is separate, you can scale whatever you want up to whatever intent you need. So if you want to scale something, you can scale either up or scale out. The advised approach is always scale out, but you can pick and choose what you need. So scalability is always easy. The reason when I say scalability is easy because you are not scaling everything. Now, let me tell you one thing. We at T-Mobile launched when this new Apple phone was launching a few months ago, I think in September 2019 it did. Then, believe it or not, every single website in the world was down, but not the T-Mobile one. We were so prepared for it because we are 100% microservice organization. All our domains are microservice. So we have a separate team, dedicated team for payment. We call it DPS. We call it digital payment services. We have an orders team. We have a customers team. We have team for billing. We call it DBS, digital billing services. We have inventory. We have order management domain. We have document management domain. We have legal. We have fraud, collections. When you go and buy a phone on installments, we have a separate team for that called EIP. It's called Equipment Installment Plan. So, and then we have inventory, and then we have fulfillment that is happened by SAP, right? So all these things are there, and every team is following microservices. So every team was so on their foot to scale their services on that night when Apple launch happened, and we placed like few 100,000 orders, and our website did not go down even for a minute. Whereas even Apple website, believe it or not, Apple's own website has downtime. It was in news. Every other competitor of ours has downtime. It was in news, right? So Vittal, thank you so much for replying messages to people. I appreciate that. Keep replying whatever you feel, and later on I will see what I can get from this chat messages, but I'm not in a position to do both the things on my own. But do not bother so much. If you have any questions, document those down somewhere. note it down in a book or the laptop and send it to me later on. I would love to answer personally everybody's question later on as much as I can. So what we did that night is we scaled a payment service, we scaled order service, we scaled shipping service, and then inventory service. We don't need billing service. Nobody is asking it that night, what does my bill look like? Can you download my bill for past 3 months? Can you change my billing address? There was no customer who was asking us to change their phone numbers and all because those launches happen midnight. Like it will open like 12 a.m. in the night and until morning you can place the order. It's like pre-ordering a latest Apple phone, like phone 10X or 11, whatever terminology they follow, right? So what we did, our focus was on those services which were taking the most load. What we did, we checked the inventory. Okay, do we have it by the time customer wants it? Can we handle that much load? Yes, inventory says yes, we can. We have it. All right, place the order. I want rose gold. Do I have rose gold? Okay, I have. Place the order. Payment was so much hit because you need to deposit money to do the pre-order, right? And then shipment. Shipping team needs to be notified. Okay, this person placed the order. When you receive from the inventory, ship it to this address and then submit that to payment so they can fulfill the rest of the remaining payment. You know that when you place an order, no company can charge you legally unless that order is shipped. So they charge you when order is being shipped. So what payment team was doing that night? They were locking that much credit after your card authorization into our system, and we will process that much payment, whatever $1,000, $1,200 on the day when we ship it. So think about the connection between two systems that when shipping domain is ready to ship and the label is generated, a notification goes to payment team by Kafka or any Azure notification hub. There are multiple technologies. We are not on Microsoft, so we use Kafka for notifications and all, or whatever, right? A notification will be sent, an event basically, and payment team will run the payment and secure $1,200 from that credit card where we were holding that money, but we didn't take it out, right? So we scaled all those services that night. Um, Easier deployments. You can deploy whatever you need. You are not deploying everything. A problem isolation. Since everything is separate, your problem is isolated. If customer is down, payment doesn't know. If there is an issue or a service attack on customer's, payment doesn't know. But if it is your monolith, if there is a denial of service attack, your everything will go down. Single responsibility principle is first principle of solid design principles. A single responsibility can be followed when you do MVC. You are creating each controller by yourself, but this is a single responsibility because that customer controller which you had in your monolith or MVC application, that customer controller now is a project by itself. There is no other thing. But in normal MVC or SOA, you have customer, order, payment. Everything is a controller, but they all live together. Here, they all live separate projects and have a separate pipeline for deployment. Deep domain knowledge, as I said, like I own the architecture if I want to call it verticals, I own the payment and orders vertical. I had other fellow architects who were owning activations and customer account management and things like that. So you build up some domain knowledge around it when you work with those teams. I was talking to our DPS team. I was talking to order management team, how they do things. So you build some knowledge about that domain, whatever you own. A polyglot programming. Polyglot means multiple languages. Since all these services are scattered, if you want, you can use different programming languages to build these microservices. Customer microservice can be built using C#, Java, Golang, Java Spring Boot, and few more if you want, Python or whatever, right? So this is the benefit, but it has its own disadvantages. At T-Mobile, we do not believe in that. We are using only Java Spring Boot. The advantages are that you are not depending upon so many different technologies when you review code of each other, and then you are buying in and investing into one technology which is proven in industry for that particular purpose, like microservices. You can use .NET Core today. You can use Spring Boot from Java and all these things. So we are not polyglot, but many startups and all, they do it. It is not recommended. It has its own disadvantages, but many companies are open for that. Now, let's talk about some disadvantages. So the first problem, biggest problem of microservices is nobody can begin with microservices unless there is a cultural change in your organization. Many times this cultural change comes with a very fancy word known as digital transformation. Digital transformation is the term which is used when many organizations are transforming to go and adopt the greatest and latest in industry today, which is microservices, cloud native, going completely on cloud and all that stuff. So it's a cultural change. You cannot wake up one fine day and say, okay, tomorrow we will starting microservice. It won't work that way. Because what if you did your controllers in microservice, but your backends are all still together, right? You still go to one big team who has their own monolith, then you achieve nothing. So it has to be achieved end to end, even from your domain to the backend domain where you are getting the things and your database as well. Safi uh, said something about using other languages, but that's okay. Uh, there are few good more questions coming about multiple calls, and Srilal mentioned it. So I will read those and do it later. The other one is more expensive. More expensive in a way because what happens, so keep typing questions, but I'm not in a position to answer. That's what I'm saying, and I think that's what Shivang also meant to people. Um, Now, more expensive in a way, think about it this. Now, earlier you were doing everything together by a team of, let's say, 4 or 5 devs. You were able to pull everything together, and there was one single pipeline. Pipeline means CI/CD pipeline, DevOps, right? And you were able to deploy everything together. There was only one project which you open in the morning, solution, and then everything loads there. You are happy about it. Everything works fine. One database to take care of. Now, when you break it apart, think about it, how many moving parts you have, right? Moving parts are, you have customer project, then their database, then this, then that. All these things are separate. You need these many projects. You need these many code repositories to host the project. You could be on Azure DevOps. You could be on a GitHub. You could be on GitLab. Whatever you use, you need a separate repository, separate code review process, separate databases. And the disadvantage, I think somebody was trying to mention as well in their question is, if I am connecting it right, that now, how would you connect tables? Earlier, it was a connection. When you do this thing, there is no join happening. There is no primary key, foreign key. It's a big trouble, right? So all these things will evolve, and hence you need more time, more thinking, and it's more expensive, and of course complex, as I just mentioned. Less productivity. Many people call it it's more productive. It becomes productive to that team by itself, who is working on customer only, but it is less productive in a way because there are so many moving parts and you have to connect so many dots. Think about a jigsaw puzzle. You know, the puzzle which comes in different pieces and you have to put all the pieces in right place to make it work. The same situation happens here. So unless you really build the proper rhythm with microservices, you build that mindset, you have that culture in you, and you have the attitude and the mindset of agile, DevOps, all these good things, and you know your technology and your domain, and every team is so good at doing their thing, what they are supposed to do, then it will be productive. But otherwise, it's less productive. Now, communication between services. You see, everything is now a REST call, a call over the network, right? Everything is a REST call going over a network. Hence, there will be some latency and all. Harder to do integration tests. If somebody is so passionate about testing, integration testing could be a problem. We at T-Mobile have this problem all the time. Many times my customer domain, my payment service is ready, right? But let's say my DPS domain, digital payment services, which is our T-Mobile's own domain, which go out and then work with WordPay and other acquirers in industry to get the payment processed. What happens if they are down or they are not ready with the microservice, which the contract they shared with us? How do I do my test? I cannot, right? So we at T-Mobile are heavily using virtualization as well. So the good thing is, what we at least are leader in industry in that manner is that we are very strict about the having contract between the services. Contract means your Swagger contract, your definition. Remember, on interfaces, you should not change the contract of the interface, right? So if you tell me, if I hit this endpoint and I pass you this, you will give me this, this, this. That's what we want to lock on, and they cannot change it without triggering a service change request. So they cannot break that behavior for a customer because I am a customer for them. I'm a consumer of their microservice, right? And then my microservice is being used by the application UI, which you see on the top here. So I can talk in greater length to these things, but I have to keep on moving. Well thought architecture right from beginning. So we need to think about that architecture from the beginning. You cannot just jump into microservices without proper thinking and alignment. Uh, the next one is how to migrate from monolith to microservice. This is all pictorial. Of course, don't switch from microservice monolith to microservice all at once. Take baby steps. I call it like crawl, walk, and run approach. And of course, divide and conquer will help. What you do is you look for your monolith system. Let's say, think about it, what you might have, or I have great experience in that. I have built those projects many times. And as I was just trying to create a visual mind map for you guys is, um, think of your MVC project where you have multiple controllers. Just visualize it in your mind. You open your solution, you open an MVC project, you have a customer controller.cs, order controller.cs, payment controller.cs, and you have a data access layer which has a repository pattern implemented, and it is going to a SQL server which is deployed somewhere, but it's one big monolithic database. Now, how would you convert it to monolith to microservice? Take just one controller out. So take that one payment controller, for example, and its model, view model on the server side, whatever you need to do. Take that out in a separate project. Call it payment microservice.sln and create payment controller.cs, model classes, all that folder is structured there. Bring the repository code also there, only for payment. Now point it to the same large SQL Server database and see if it works. If it works, very good. You did something, and then build a separate pipeline for payment controller, deploy payment service separately. Let it hit the same monolithic database. Now, next step is take the payment tables out into SQL, NoSQL. I will talk about it later about the patterns to be followed. And then you follow the same approach for other services. So you see here, transform that part into a microservice. Inspect the monolith system first to see where it hurts the most. When I say hurts the most means like what was giving the trouble to scale or make it performant or make it like deploy all or none. Like I gave you our examples where we have to accomplish a greater extent of scalability. So you may have your own definition of what is being hurt where, but take small steps. If your organization is not doing microservices, you can do it on your own. As I just gave you the sort of advice how to do it, you can follow the same approach. If I'm pronouncing the name right, then I will try. Otherwise, please I apologize if I mispronounce your name. Wasabi said how to convert an existing monolith to microservice. Simply, I believe when there is one DB for all domains. That's what I was just explaining, Wasabi, if you heard me. The next thing is service ownership. So when there are different microservices, one team cannot own all the microservices. As I gave you my example, my real world, my personal experience at T-Mobile, we follow the same as well. All the architects, all the leads are not owning every single thing. The problem is you will miss something. So for example, here you see team one owns one circle, then other circle, then other circle. So shipping is left out, first of all, here. This is just a hypothetical situation created, but this can happen anywhere. And order service is being owned by team one and team two both, as you can see. So service ownership is very important. I wrote an article, it's on my blog as well and on LinkedIn as well. You can find it if you will search the same word is STOSA, single team owned service architecture, which means each thing should be owned by one team only. So for example, we have a dedicated team for payment calling it DPS, which is our T-Mobile own backend team, which talks to rest of the world outside services, Visa, MasterCard, WorldPay, payment acquirers and all, right? They have their own algorithms for everything. How to encrypt the credit card. They give us the token to encrypt the credit card information and all. But within our customer side, when we are building applications, the UI, the front end for our web users, retail, care, there also we had a microservice team. And that microservice team, like I was the architect for that. So I was owning payment and order. So Me personally, I was responsible for two services, means no other architect can touch it. If any change needed, I am the one to be contacted first. So we call it single team own service architecture. However, one person can own multiple services, but multiple people should not own one service. When I say that, don't take it that multiple devs cannot work on it. That's not the intent. I'm talking in terms of teams, not individuals. I hope you will make sense. I highly recommend to go read about it. I have explained it in text as well. A little bit about DevOps thing. I will bring real quick both the slides, both the images here. So delivery cycle for Monolith, many of you might have heard that Amazon deploys every single second, Netflix deploy every single second. At T-Mobile, we also does not that rate, but we are very quick to deploy. We follow trunk-based development. The thing is that if you do Monolith, what happens here is that you have a very big code you are collecting over the period of time. You see that? All that code is so big boxes. It means this much amount of code you are collecting and then you are deploying at once. Whereas with microservice, the change is small. So something change in customer, you deploy it. Something change in payment, you deploy it. So your change is very small, and hence it makes more sense to have microservices where change is small, and hence you will have other benefits in DevOps. Now, the next one is Devops Practices. These all are Devops practices. I will just quickly let you stare at it, like CI/CD, infrastructure as a code, test automation, and all. Now, there are some Devops metrics with microservices which really help. With microservices architecture, your deployment frequency really increases. You can deploy as many times as you want because you are deploying small changes. A change lead time is very short. That means since you have small services, change lead time is that when you get a requirement, when you start making a change, how soon can you deploy it? So that cycle, that time length or that piece of time is very small when you can do it. A change fail rate. Change fail rate means that how many times have you experienced that you deploy something and it fails in production, then you have to undeploy it or fix it later, right? Things like that. So change fail rate really significantly goes down, as you can see. As you can see these lines going down. What does it mean is since you are deploying a small change, and if the change is small, you have small number of commits in that change, and hence the fail rate will significantly go down. A mean time MTTR, we call it. MTTR is mean time to repair. That means is that how long does it take for you to detect a bug or an issue in your code and then fix it and then deploy it. Since your microservice is so focused only on one domain, right? If I'm looking at payment and there is an issue with payment, I'm only focusing on payment domain. There is no reason I will look for customer this, that, right? I want to make sure that this one thing is well-rounded and working just fine. I will run my sanity tests again. I will run all my unit tests again and make sure that no contract is broken and all that, right? Or if I need to even make an enhancement, I will do it real quick and deploy it. So your mean time to repair is significantly improved on that as well. Now, this is about handling unpredictable failure. This is a real screen from my younger daughter's Netflix. So what happens here is I'm using Netflix as example. Here, what they do is they show you these ribbons, like this flat thingy, right? Everyone watching, watch it again, continue watching. Now, every single thing in Netflix is a microservice. So Praneeth asked, do you recommend breaking down the payment services itself into multiple services? This question is sort of open-ended. Ping me later. I can help you with that. I will see if I can save this chat before I end the call. Maybe Shivang, if possible for you, you don't have to answer since everybody is on mute. If possible, see if you can copy this chat somewhere, if it allows, and then I will go through the questions, but I can answer that question for you later.
All right, I'll try.
So here, watch it again and all these things. Now, what happens is everything is a microservice. Think about you are on your TV and you are on Netflix. since everything is coming from a microservice and continue watching, microservice goes down, right? Everything is being pulled from your profile database somewhere, right? And based upon what you watched, they want to recommend what other people are watching. And what you have watched, they want to tell you watch it again, right? Now, all these things are coming from somewhere. They have databases, SQL, NoSQL, they maintain your state, they know who you are from your profile, they know your interests, they are tracking what you have been watching, they are predicting what you may like to watch. And one of those microservices go down, what will happen? You will never realize it, my friends. That banner, this slider thing will go away from there, and you will see something like trending now. They automatically, it's a responsive UI, it will automatically adjust the screen in a way that you will never know continue watching is not there. And we in today's world are so overloaded with information. We will keep doing up and down with the remote. And since they are microservices, when I say they are, even ours also, everybody who is investing in microservice have to follow that way, are containerized, running in multiple regions. They are so resilient and they are foolproof. Even if they fail, they have a mechanism to retry circuit breakers and all that, bring data from the cache and whatnot. You will see response back within milliseconds. The moment you do up and down, the banner will appear again, continue watching, and you will say, oh, here it is. And you will begin with it, right? So that's the approach what people are following. And this is an example for that. Now, 2-second rule, I don't know how many of you really know about it or not. 2-second rule says that, like Amazon and all follows it. We at T-Mobile also follow the same. 2-second rule is a very loose principle. What it says is that users should not wait more than 2 seconds for anything, right? Uh, when I talk about it, users should not wait, what does it mean? What it means is that whatever you do, it should be done in 2 seconds. So let's say I'm processing a payment. If you process a payment on Amazon, you place an order, you click on it and it's gone. You just receive the order confirmation number. That's what happens there, right? Now, let me give you a scenario. So think about it this way, that when I'm placing the order, they are going to the inventory system, checking how many quantities are there, whether they have enough or not. And then they go to the shipment and check, can you ship it to this zip address or not? Then they go to order domain, say, okay, have you received the order or not? Can you confirm it? If they do all these things, it cannot be done in 2 seconds because everything is microservice. They have to make multiple hops. There is a network latency. What if one service is down? Can you continue to wait? No. So what you do, you click, your order is placed. This has happened with me multiple times. It's a real email I am sharing here as is. So I was buying a book and then I placed the order. It went through. After a few days, I received this email that your order cannot be fulfilled, it's canceled. So how does it happen? Does it mean Amazon didn't know there is no book in the inventory? So what happens is, I will tell you how it works. They always keep a count of inventory, but whatever is the last known, they know that, okay, there were 200 books. I think we already have enough. And they keep checking it time to time. But many times what happens is the state you received of the resource, that is not up to date, right? You have availability, but you do not have consistency. So in those situations, what happens, since they are following 2-second rule, I clicked, I bought the book, they will see if they can fulfill it from other warehouse or something. But many times they cannot. So later on, when order domain really submit it to inventory and check it, they figured out, oh, this thing is out, we are not able to fulfill it, and hence they cancel it. And as I said, unless or until they ship your order, any company who is in this business, like even we, T-Mobile, do the same, unless or until your order is being shipped, your credit card is not charged. However, they lock that much amount on your credit limit. So this is one situation where they are very loosely coupled using microservices and all that good stuff behind the scenes. There are more details to it, but I think you got the idea. Now, there are 2 patterns I want to talk about. First pattern is called Bulkhead Pattern. What Bulkhead Pattern does, bulkhead is a term which came from the ships, boats. You see these vertical lines in this boat here? This section is one bulkhead, this section is one bulkhead, this is one bulkhead. All the ships, cruises, everything has it, even spaceships has it. What it means is that you are separating one entire big thing into small pieces. So if one thing is filled with water or compromised, then the other thing, the entire ship, is not compromised. That's what a bulkhead is. So many times what we do when we design microservices, look at the left one. So you have a microservice, there is a connection pool, and which is depending upon two backend services, microservice X and Y. Now think about it that for some reason microservice X is taking more time to respond back, or taking more, data from you, and your connection pool is really overloaded with microservice. Then microservice Y will also suffer because you have a common connection pool. You need to see from microservice A how much traffic I'm sending to X and how much to Y. If there is a disbalance between two, then it's advisable to have two different connection pools. The problems are unusual demand, noisy neighbor, propagation of failure. So if there is a call coming A to Y and there is a failure, then it can pollute the entire connection pool, and then you will lose connection with X also. So if there is any such thing, I will give you one real world example real quick after that. What you need to do is you need to follow a two separate pool process. So have pool for X, pool for Y. And if there is any problem with Y, X is not suffered or polluted, right? So we at T-Mobile were doing something where we had a microservice, and we wanted to do the normal processing and then the bulk processing. So when we do bulk processing, think about bulk is we are processing lines which has like 1500 telephone lines in it, or 200 or 100 or 1000, whatever, right? But it's not like one or two, the regular thing. Can I keep the same thing in the same connection pool? Answer is no. You should never do that, because the bulk processor is having more load than the normal one. So if both run at the same time, the connection pool will be so consumed with bulk processor, and it can hinder your regular experience for one or two line users, right? So think it that way and keep it separate. Now, when we talk about implementing patterns for microservices, there is a very important pattern called CQRS, which stands for Command Query Responsibility Segregation Pattern. Here, what we say is that keep read and write separate. So if you write to one database, but you read from a different one, because in industry, reads are always more than writes. That's a proven fact. So there are greater details to it. You can go and search about it, how it works. It's not that complicated to implement. The only thing I want to leave you today with is a CQRS pattern where user does write the post events, and those go to the one database store, which is usually relational. And after that, the read side happens from a different one, which is usually NoSQL for faster partitioning and distributed and all that stuff. So read happens from the other database. Having said that, when that domain who owns the data at the bottom, they will give you two URLs for REST. One is post, one is get. And when they give you get, when you hit their get, they know where to point it to. You don't need to know that. And when you hit post, they know where the post will go to. So they have that thing within their domain. You need not to do anything. And hence it says command and query. Command means your create, update, and delete. In CRUD, if you know CRUD, CRUD, when we do a repository pattern or writing code for data access. And query is simply, when you select a stuff, you search a stuff. Now, the next one is evolutionary architecture. What happens here is this is Monolith we talked about. This was yesterday. People were combining front end and back end. This is sort of thing what we have like a SOA or controllers and all, where your UI code is separate and your controllers are separate. Present is microservice. You have Monolith front end, one big Angular app. Then there is an API gateway, and then there is a product API, basket API, advert API. Like think of separate databases and all, right? But we at T-Mobile are here on the future one, microservice and micro front end, and many organizations are doing it. So what happens is even you break your front end into small micro apps. So as I said, the domain, think of the domain terminology. So payment is a domain. My customer needs a payment capability. So what we did at T-Mobile also, we have a payment micro app. So whenever customer clicks on payment link, we open that payment micro app within the Angular. So think it that way. So micro app code is all separate. Micro app is all deployed separate, but there is a single sign-on and all that good stuff. Tokens will be handed off. You need to do all that thing. but it will load. See that base app, let me take a minute to explain you. See, the base app means this is your container app. Container is not the Docker container. Container means your UI, which will have your header, footer, contact us, all that information, and then basic thing, but place to load the apps when time comes. So now user want to make a payment, we load the payment app in it, you close it, your payment is submitted. But payment app lives in its own code repository, has its own CI/CD pipeline, can be scaled by itself, can be secured by itself, and when time comes, we load it in the base app context. And everything is dependent upon, of course, microservices. Each microservice has its own databases. So there are so many moving parts. The more moving parts you have, the more decisions you have to make. One more thing, since I talked about micro app, this is the last slide. So hang on tight for a few more minutes. A micro app ownership, many times people think, I have seen in industry that they think that if I have 3 micro app, A, B, and C, one team should own styling, second team should own forms, and then third team should own validation, fourth team should own API call from JavaScript or whatever to backend. That's the wrong pattern. Don't do it. Always do entire stack. Okay. So avoid horizontal, own the entire thing. So we do the same. We have one team which owns the payment micro app, the other team owns the checkout micro app, the third team owns something else, and that's how we do it. Okay. So this is the end of this session, and I hope you were able to learn few things about it. If anybody has to drop, you can. Otherwise, I can take some questions from the chat, or if anybody wants to unmute yourself and ask your question, I'm okay with it. Go ahead.
Hey Vidya, thanks for the session. It's extremely helpful. I have one question. With this microservices architecture, we have multiple teams available, right? So the interface should be tied between each team. When I say each team, each services. Now, if you want to introduce some new change, it depends on other teams' priority, all those things, right? So uh, how do we take this up? Is there any better way to handle all this?
May I know who was talking?
Okay, this is Rajaram.
Rajaram, okay. So this is a very complicated situation. We have the same situation all the time. And that's why when you do this, you have to align your product roadmap. I call it product intentionally because product needs a different mindset. So you have to have your product roadmap and find your dependencies and align with them. However, by the time that team is building microservices, you do not need to wait. You just need to lock on the contract with them. So work on swaggers if not already. Agree upon the definition, what you will pass them, what will be your request header, what will be your request body, what response you are expecting, what will you call a field, and all that stuff. Work on that contract, build your microservice, build your UI according to it. You can virtualize it, have it ready. And in the meantime, when you are kicking your legs and doing this thing, they may also align to your roadmap from leadership. If leadership can really help them to prioritize on it, and then they do it. And once they are ready, you just suck their data and load it. The only thing they have to do is they cannot break the contract. As I said, it has, at the beginning, I said microservice is all about cultural change. So if any organization is in this way, no, I will not do it. I will do whenever I want. It will never work. It's like in my podcast, which I did with Mario, you can hear to that. It's like different cogs in a clock, small wheels in a clock. Every wheel is stuck into each other. And when one wheel's move, every other wheels move as well. So it's more like that. But if that team is not ready within the timeline, let's say they are one sprint behind and your current sprint has bandwidth, then you can begin with UI development and parallelly work with them, as I said earlier, on the Swagger contract locking. Once you lock the contract, let them do it, and you can do virtualization, test it, and when they give you the real endpoint, you hit it and consume it. There might be some issues, but you can work with them to fix.
Cool. Thank you.
You're welcome.
Yeah, this is Prashant Kumar from Pune, India. I have two questions. My first question is that, as you mentioned, the microservice architecture is having some more cost inside it. So, means in Azure cloud perspective, to divide any component at the granular level, we can use serverless architecture along with Azure DevOps, where we can get the auto scaling and all the steps with very lowest cost. So how this can lead to the additional cost than monolithic approach?
Okay,
And
very
my
good. Yeah, go ahead. Tell you another question. I'm listening.
Okay, and my second question is now if we are dividing any application and breaking into the different components to execute certain process inside it, and if we have IoT applications where controller sends millions of messages per second and that needs to be processed very instantly and very quickly, so how this microservice architecture can help or can improve in IoT applications? And apart from this, I have a very basic question. Can IoT applications be developed in microservice pattern? Yeah, that's it from my side.
Okay, so I will take it bottom up. So any application can be developed in microservices if your IoT is related to, think about it, it's sending events, right? And notifications. So you have different devices. The devices may have for different domains. You may have a devices for cars. You may have devices for kids. You are tracking kids. They approach the bus or not. You may have devices for pets, like here.
Right.
A puppy dog has something in the neck. So these are domain by itself, different customers. What you may not have as many cars in the road outside, as many pets in the house in India or America, right? There are more cars than pets. So think about it. If you do monolith, you need to scale everything all together, right? But here you can scale cars separately and then pets separately. And moreover, the languages will be different. What you want to know how many times a dog bark in a house, and your IoT sensor has that thing in it. It tracks, okay, usually in America, dogs never bark in the house. Like I have a puppy dog at home, actually. We have a puppy girl. So I have been talking for last 1.5 hours almost. You didn't hear her barking. So, but sometimes she does. So all these things, right? So think about, dissect it, think from these angles, and then you can do it for sure. Anything can be done in microservice, by the way. Second question you asked about Azure thing, Azure Event Hub and serverless and all, right?
Right.
So since everything can be done and they are sending millions and millions of those, so Azure's pricing is automatically defined in that way that they know that the touch point is very small. The touch point to those events or notifications is very minute, like milliseconds. But the quantity is so much, it's like a bombardment of events, right? And that's how their pricing is done. And certainly serverless can help. And FYI, if somebody is adopting to serverless itself is a microservice architecture sort of thing. If somebody wants to write a bare minimum hello world, very simple microservice architecture, serverless will help you there as well. So you can do it.
Right.
And reach out to me separately if I am a little bit off here and there from your questions.
Okay.
Drop me a message. I can call you sometime and we can discuss it to greater length later on. And the first question you said that how it is expensive or complex. What was your question?
Yeah, in Azure cloud, the serverless architecture is having a very low cost, and considering the Azure DevOps as well,
I get it. So why it is expensive, you mean?
Right.
Okay. So how it is expensive is because you have multiple teams. If you recall my slide, single team owned service architecture.
Okay, team-wise. Okay.
Team-wise. So you have multiple CI/CD pipeline. You need more operational cost to maintain that. One person cannot expertise every domain, and it depends on domain to domain also. So do not take that statement as a blanket statement that it is applicable to everything. Think about you are building an in-house application and you are following microservice for whatever reason, which is not advised. But if you are doing it, then you can handle everything on your own, right? But we as T-Mobile or Amazon, Netflix, Facebook, whoever is doing everywhere else, any large organization who is serving millions of customers, they have multiple teams. So in T-Mobile today, we have like more than 200 microservices, and we have more than 200 APIs and more than 50 microservices, right? Okay. So think about it, how many code repositories we have. At any given time, we have like more than 50, 60 code repositories. For each microservice, there is a separate code repository. There is a separate, separate CI/CD pipeline. So in that manner, it's a little bit expensive and complex.
Okay, yeah, got it. Thank you. I appreciate it.
Any other question?
With the Yogesh here, in the slide 19, right, in CQRS, you're saying like separation of the responsibility, like the read and write. So I'm confused. Like you suggesting like two different microservices, or this is just one
No,
microservice?
no, this is one
Uh,
microservice. This is one microservice. That microservice will have two different APIs in it. One is for read, one is for write, and two separate databases.
okay.
Write is usually relational, and read is usually non-relational.
Okay. So is this the like always a pattern or the best suggested way? Like,
This is
or
this
this
is
is the
this is
always we should follow?
this is what you should follow, and it also depends on the number of users you have. So as I said, usually reads are more than writes. That's why this is the advised pattern for microservices architecture. And other thing is, if you see, you are also not taking the load when writes are happening on the reads in the same database, right? Because otherwise your source of truth is same.
Yeah. Yeah.
So the only complexity to it is which I did not cover here to greater length, is the event sourcing. You have to establish some sort of event. So we use Kafka for those event syncing. Whenever a write happens, so there is a post. That post goes to the write instance, relational data store. Immediately, an event will be fired up, and then that change will be sent to the NoSQL thing, and it will be written into the NoSQL instance with the change. So let's say I change my address, right? So it will be happening from post to the write instance relational data store. And after 5 minutes, I want to go and read if my address changed or not. That's the use case, right? Then
Okay.
that event will automatically update the read replica of the data store with the help of an event. And when I read again after a few seconds or few minutes or whatever, then you will see your updated address there.
Okay.
And this also, one more thing it does is it provides the scalability. So if I want to talk about system design, which is a totally separate topic altogether, not many people think about that usually. When we talk about system design, in system designing, to scale it, you need this approach, CQRS.
Hey Vidya, Praneeth here.
Yes, Praneeth.
Would you like to double click into payment services split down? Is it an overkill, or do you think that there is a need to split payment service into multiple microservices? The context that I'm coming from is, let's consider we have quite a few payment methods across the regions. So do you suggest it splitting it across the regions or across the payment methods so that I can take the benefits of fault tolerance as well as resiliency of the
A
instance?
very good point. I am yet to write a detailed article on it. I think I will take some time this week and do it. So very good question. Thank you so much for asking. Really appreciate that. I have an answer to it. So what happens is many times we only talk about microservices architecture in terms of entire stack, like UI to backend and all that. But we never talk about what about the domain itself, how payment domain is dividing into microservice. Can they still be monolith, or they still need to divide into microservice, right? That's what your question is. So the
Yeah.
answer to that is yes, you should do it. First of all, unless or until your regions are like Azure regions or AWS region, East, West, whatever you have, are not designed to cater to those only, and they are not designed in a failover mechanism that if East is down, traffic will go to West, then you can divide your microservices and put it only in that region. Otherwise, I would recommend divide into microservice for sure. Look for the customer segment. I will give you our T-Mobile example, right? So, and maybe that will relate to you as well. So T-Mobile, we are in a very unique spot where I have experience to all the things. I have experience to B2B, B2C, retail, web, care, IVR. When you dial the phone number, press 1, press 2, it triggers API calls and all in the background. So what happens here is our microservices, even in the domains, are divided to per the capability. So we have assisted channel. Assisted channel is you go into retail store, you go into care store. right? So care and retail, these two things are different API sets. Then we have a web channel, unassisted channel, where customer can go to the account, log in, order devices, change their address, change their services and all. So those are different services for web user, right? Different authentication mechanism and all. So think from that perspective, divide it. Other thing is we have, I think that may apply to your domain as well, which the industry you are in. We also have two scenarios. One is called a CP and the other one is called CNP. CP is card present. Card present means when you go to a device, you slide in the card, tap the card, insert the chip, or just tap on it, right? So that is retail store, card present scenario. So there are separate microservices for that. You can use that to slide and dice, right? The other one is card not present scenario, means somebody is calling a care channel over the phone. Somebody is on the web. You are holding the credit card in your hand. You cannot slide it. You cannot tap it. You cannot insert it. You just need to punch the code, right? So all these, uh, you know, uh, things or lenses can be used on your situation and see what you come up with. Do some exercise on paper, and then you can certainly divide it per capability. I cannot answer about your failover mechanism, the reason why, unless I have the greater, some more detailed information about it. But I think I tried to answer your question in a way that certainly you should do it, and these lenses you can use to divide. Okay.
Yeah, thanks.
Hello, this is Amit. So this is on context with the slide CQRS. So let's say I have an update database, and if I want to scale that database, so is it possible to scale it horizontally? And yes, how will we manage the consistency in the increased instances?
So, Amit, first of all, when you say update data store, I think you are reading from the slide itself. What I meant here is that you're right, your new record addition, your deletion, and then updates also. So in this case, you cannot, since it is, if it is a relational data store, read my article on CAP theorem, CAP, CAP theorem. It's on my blog. It was on my LinkedIn posts as well. If you will go to my LinkedIn, look for the activities, you will find the CAP theorem article. I try to explain the same in greater length. With relational data store, what happens is you cannot, it's not like NoSQL. You cannot distribute it like that. So you may have different instances of it, either in the same region, different. If you are in a region, you can have availability zones. Even if you are across the region, then you cannot do it to the way what NoSQL supports the scalability, but you can scale it up and scale out to a certain extent, and you have to establish the read replicas of that as well, or the replication between the two copies. However, it is very unlikely that you will achieve, consistency and availability at the same time. So that is sort of thing. I would highly recommend one more time, read the CAP theorem article I wrote. Then that will clear some of your doubts. And if still you have some issues, then reach out to me and we can talk about it.
Sure. Thanks. Great. Thank you very much.
You're
Vidya,
welcome.
if I can add to that, probably I think that is the very reason of CQRS platform, right? So if you look
Yes.
at CAP theorem, you cannot have all the three things at once. If there is a partition, you can just have only
Correct.
availability or consistency.
Exactly. So
I think, yeah, if you have these separated, then you can scale them independently. Probably for reads, you can go with NoSQL. For writes, you can go with RDBMS, where you get the consistency.
correct.
Sorry,
So
Vidya.
no, you are right. Thank you so much for that, Pranit, chiming in. I appreciate that. And we need more participation like that. So let's continue with this in future sessions as well. And one more thing is, if you recall that screenshot I was showing about Amazon's order failure. So that happened because Amazon's is also on AP. They are on availability and partitioning, not consistency. So they couldn't figure out whether thing is in the stock or not, and they took my order, but later on they canceled it, which is fine. And that happens like once in a few 100,000 instances, because they are so overloaded with, and they can find within their internal warehouses, if not from here, from other state and whatnot. But they follow AB, availability and partitioning. So service is always available and partition, but not consistent. So read about CAP theorem. For everybody, I recommend to read it. I try to document that article in a very simple way. and I spend a lot of time on documenting it, but see if that helps you. Okay, I can spend a few more minutes if anyone has questions. I see people are dropping, which is fine because it's office hours. For me also, it's office time, but I can still hang on here.
You talked about enforcing that service request process whenever in the ecosystem, if one of the team is changing service contract, then you're enforcing that they need to get the service request approved, only then they can go ahead and do that, right? So do you have any such enforcements, any more such enforcement to keep all the ecosystem intact?
I'm sorry, enforcement in ecosystem. Can you repeat the last part for me, please?
Oh, okay, I really like the idea of service teams notifying other teams about
Oh, okay. I get it. I
the
get it.
changes.
So,
Yeah.
right. So basically, it's a process. See, I'm not saying any company or any team needs to be so heavy on processes. Okay. I'm passionate about people, process, and technology. Because without people, technology cannot do anything, and without process, people cannot do anything. So these three things go hand in hand. Now, what happens here is that you have to work with your leadership or project management team or whatever, that we have to, adhere to a service change request process. If they are changing something for whatever reason, many times one service serves different customers. That's what they do. So they will see my team name. Okay, if you are coming from XYZ, I give you this. If you are coming from ABC, I give you this, which is fine. That's their orchestration logic, right? Let them do it. But many times they change something which they feel, oh, that was in the next sprint, we are putting it in here because you will need it tomorrow, which is fine. But your contract should not be broken. So they need to be careful about putting optional, required, and things like that. So I would say work with either, if you are so, a cohesive team, and teams go well together, then start that conversation by yourself. But if it is more bureaucratic and political environment, then I would say go with leadership and let it come from top to bottom to those leaders and say, okay, you are our dependency, you are breaking our customer experience, and we cannot let customer feel the pain. So you need to tell us what you are changing beforehand and what is your SLA, and try not to break our change. So it can be easily accomplished by version 1 and version 2, and they can continue to support your version 1. They can do version 2, educate you about version 2, and slowly ask you to onboard to version 2 if that is the need.
No, I think I got that. So I really like the idea of service change request, right? We have to put a process in place, otherwise
Exactly.
it would be too
So
difficult.
Correct. I will tell you, right. I will tell you one more thing. At T-Mobile, our domains are very mature. I really like the way they do. Not all, but most of the time, people process. So they even publish a documentation. Documentation is like we have one repository. In TOGAF terminology, there is a term called architecture repository. So what architecture repository says is architecture repository is where you put all your artifacts, code. So we have one repository on Bitbucket where we put all our swaggers for all the domains. So at any given time, I can go and look at any domain swagger. Then they publish a Word document where they describe each and every field, what is the purpose, what are the values, and all that stuff. And then if there is a change, they will send me the updated documentation and set up a meeting with us, titling it service change request. They will invite our analysts, architects, dev leads, and explain us what they are trying to do and why. And if we pressurize and push that, no, you should not do it, then they will take the versioning route or whatever. Many times we say, okay, we can accommodate it. It's an easy change. Can you make it optional and things like that? But it's more like conversation. I cannot prescribe everything here on the call, but it takes time to understand and work with them, right?
Okay, so it's all the manual process currently. It's not quite a automated process where you can just put a publish it and other subscribers can actually get a notification.
You can do that. Usually it happens, as I said, it's in the code repo, so Bitbucket will get it. But the idea is, how much can you explain in a notification why you are making that change? Sometimes you have to talk to people and explain them, right? Every single concern cannot be just addressed. And many times I will tell you, we have seen issues like that where notifications are coming and how many people are looking at notifications, right? That's another problem. So sometimes it's like a two-way conversation. We ask them, oh, you are sending me V. and then my microservice need to convert V to Visa. Could you please send me Visa itself? You are sending me M. Could you please send me MasterCard itself? You understand what I mean?
Yeah,
So
yeah.
we also negotiate on how much work I need to do after they send me something raw like that. V for Visa, MC for MasterCard, AX for Amex, American Express. You see? So we negotiate those things and they say, okay, we can do it for you. You don't need to orchestrate that. Otherwise, it's a load on my microservice to receive V from them, or UI will do it. I will give it to UI and UI will convert V to Visa and all that stuff.
Right. Yeah, I think that be
All
good.
those, right. So all those things can go in conversation and take it to next level with them and build relationship as well. So that's how we do it. We always take it on a call, but yes, we have notifications and everything in place.
I think I really like the idea of service change request forum or whatever, right? So do you have any more such process checks in place where you would really have a control of this microservices ecosystem?
Yes, we do. So when I was owning the architecture for payment and order management, even the domain cannot change anything without me reviewing it, because I was a consumer architect, right? I was on the consumer side. So I am the frontline team. Frontline means all our UI applications running out there are UX. Yeah, it's all us. And then we have our own a few hundred microservices and experience microservice and container, Kubernetes and all that stuff, right? On AWS and data centers and all. So whenever they were making a change in Swagger or whatever, I have to approve their change. We have that also in place. So we also collaborate on code reviews. That okay, you made this change, we agree upon it. And many times I have participated in greater length to the discussions how domain is solving that problem. Okay, why don't you put it in a queue? Why don't you retry it by yourself? Why do I have to retry it? You understand what I mean? And their error messaging, why do you give me just one-liner error message? Something went wrong. What does something went wrong? Tell me, credit card number is wrong. Expiration is wrong. What did you find wrong, correct? Because I need to respond back to the user. So think from those perspectives, and possibilities are unlimited. But we can talk offline if you have to. Okay, ping me if you need more time on that.
No, I don't have any specific questions, but I'm just overwhelmed by the humongous number of microservices that we might need to come up in an e-commerce architecture, right?
No, I think you are asking all good questions, so that's okay.
Yeah, I guess I have one question, Shivang. So I think you mentioned in one of the slides that a microservices architecture might just turn out to be a little bit more expensive compared to monolithic. So are you factoring in things like a really low recovery point objective, recovery time objective, ensuring that sessions do not terminate in case an instance goes down and so on and so forth? And these might definitely contribute to an increased cost. But can you think of any other reasons that might also increase the cost when we go about implementing a microservice architecture or doing a conversion of that kind?
So, I mean, yes, of course, all these things will happen. But in microservice, as I said earlier, there are so many moving parts. And the more moving parts you have, more decisions you have to make. So when you say session timeouts and all, it will continue to happen. A session timeout is usually for your UIs, but for microservice land, the timeouts and retries are very important. You have to make sure that with your backend team and all, you have an SLA defined that what is the timeout for you, how many times I need to retry, and then work upwards to the UI. If that service is not responding, what you need to show, what do you tell the customer? And many times you may have to come up with new user interfaces, new use case scenarios of what to do. For example, I will give you one example from T-Mobile we did. What if our DPS service is down? What do we do? And customer is standing in the retail store, want to make payment. And usually people don't carry cash. If you don't have cash and you want to pay by card and my DPS service is not connecting, then what do I do? So we built a brand new feature, call it Knuckle Buster. Knuckle Buster is like a small device. It's a very old fashioned. where you put your credit card in. It has a carbon copy side of thing in it. You slide that left and right, and it takes the imprint of your credit card. You get the sign of the customer, and then you need to punch in those credit card details later on into the UI. So we built a separate UI for that within the application to punch in those things and send it to DPS. And whenever they become available, they will run it separately as a transaction. But we have given the device to customer without really having money in hand. So you need to think more in those lines. But once again, I will say for everyone's benefit is that the more moving parts, more decisions to make. But if you have something which I did not answer to your satisfaction, ping me offline, and we can either talk or I will respond to your messages. Okay.
Yeah. Thank you.
Vidya,
All right.
I
Who is
have
this?
last question. Can I ask? This is Prashant again from Pune.
Yes, Prashant.
Yep. Say now the technology is changing very rapidly. So will that be a good idea to change any large ERP applications to this microservice from monolithic at this moment? What is your opinion on this?
Yes. The problem, it depends on what is the objective of ERP. So you can do it. We have one such situation where we are doing the same. So yes, you can do it. Think through it. Use some people within our organization as a soundboard, because some decisions require a lot of budget funding and there is no
Right.
comeback, and you mess up the whole thing if you go in the right direction. So many times such ideas, I would say, think through the lens of advantages of microservice, but it's also not that one size can fit all. So first understand the microservice, which I believe you do, and then see from that lens if ERP system you have is a good candidate and what benefits would you reap out of it if you implement it. And then present that readout or viewpoint to your leadership and have their buy-in, and then only begin work on it, I would say, which I'm sure you will do anyways. But yes, anything could be a good candidate.
Yeah, okay. And with respect to the technology changing, since the technology is changing very fastest way, the Microsoft is putting a lot of to the Azure cloud. So will it be a good idea to think about the technology change as well on this?
So it depends on what stack you are on. So technology change is not happening in that way. They keep launching new services. They keep launching new reasons. If you are on .NET, you can migrate to .NET Core if you want, but you don't have to. If you are already using microservice using .NET Core can be more beneficial to a certain extent, but you don't have to necessarily. Right. However, that does not mean that you keep changing your stuff. Do slow things. Like, for example, whoever was running on an EC2 or a virtual machine, it's time to go in containers. That's the change I recommend. Right. And when you do it, go with proper container image. You can take that image even to AWS. Right. AWS Elastic Kubernetes Service, EKS they call it. Or you can take it to AKS, Azure Kubernetes Service, because a Docker image is a Docker image, right? So invest more into those things. But when you say technology, if you buy into a Java Spring Boot and tomorrow you want to change to .NET Core, I would not recommend that. Stay where you are. But in the cloud, you can switch things around. You can invest more into Lambdas and all, or serverless Azure functions, but not in the languages and all, because there are few decisions in architecture which you have to make early, which are very hard to undo or change. For example, choosing a language, right? You wrote entire microservice using C#.NET, and now you want to switch to Spring Boot. That will be so, it's uphill battle. You can do it, but it's challenging.
Yeah. Okay.
Okay, I can take one more last question, guys, and after that, feel free to ping me. I have copied this entire chat. I will see what I can do. But one last question from anybody if you have. Otherwise, I will end the session. Okay, looks like no question.
Yeah, thanks, Vidya.
So thank you so much, everyone. Really appreciate it. My coordinates are here. Feel free to reach out to me and look out for my LinkedIn posts as always. And you have been so supportive on those. For the next session will be about how to become a software architect. It will be good for everyone who is already an architect, want to become an architect, or have an aspiration to be. So I will talk in greater length about those things. So, and I apologize, I went a little over, but I hope it was worth of your time. Thank you so much.
Thanks.
Thanks, Vidya. Stay safe.